Hello students, welcome to our YouTube channel Experience Tutor. Today we'll study physics concepts for pre-medical examinations, NEET, AIIMS, West Bengal Giants, etc. Today's lesson is Kinematics Acceleration. Before we start, we request you to subscribe, like and share our channel among your friends and relatives. So let us study acceleration. What is acceleration? Acceleration is the rate of change of velocity, or simply we can say rate of change of velocity is called acceleration. It is a vector quantity, means it, it has a magnitude as well as direction. Its dimension is m0 L to the power 1 t square or t to the power 2. Its unit is SI unit is meter per second square and CGS unit is centimeter per second square. What is uniform acceleration? A body is said to be an uniform acceleration if the magnitude and direction of the acceleration remains constant during the motion of that particle. Fine. The key word is magnitude and direction remains constant. Then the motion of the particle or object is called uniform acceleration. So let us see how we can explain uniform acceleration. So when a particle moves with a constant acceleration, then its path may be a straight line or a parabolic. For example, in the given two figures, here the constant acceleration, here is the example when the particle is moving in a straight line. But in this case, the particle is moving in the parabolic path. So here at any time you can see the value of A is equal to Z because it is acting under gravity. Now here we need to consider when the path of a body uh, 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 will be in a straight line with a when it is moving with a constant acceleration. So if a body starts from rest, means its initial velocity is 0, u is equal to 0, and a is constant, means acceleration is constant, then a is equal to constant, then uh, this path of the body moving is called, it will be a straight line. Okay. And when a particle moves with a variable velocity, then acceleration must be always, there must be an acceleration. Acceleration can't be 0 in that case. And next thing important about acceleration is when a particle moves continuously on the same straight line with a uniform speed, then at that in that case acceleration is 0. So if it is moving in a continuous, it is moves moving with a uniform speed in a straight line, then acceleration is 0. Remember, when a particle moves continuously in a curved path, then the uniform speed of the acceleration of the particle is non-zero. So but in a straight line, if it is moving with a very constant speed, then it is the acceleration is 0. But the same particle, if it moves with a uniform speed but in a curved path, not in a straight line, then its acceleration is not 0 because every time the direction is changing. You see here the direction of the body is this side, here the direction is this side, here the direction is this side, so it is changing. So its acceleration it has some acceleration. Yeah, it is possible that its magnitude is same, but direction, since the direction is changing, therefore it has acceleration. Acceleration cannot be non-zero. So here is the sum up what we were explaining. When a particle starts from rest and moves with a constant acceleration, its path must be a straight line. We also studied when a particle moves with a variable velocity, then the acceleration must be present. It can't be zero. When a third point, when a particle moves on a straight line with uniform speed, then the acceleration of the particle is zero. But contrary, when a particle moves continuously on a curved path with uniform speed, then the acceleration of the particle is non-zero. And always remember, uniform velocity, whenever a particle have a uniform velocity, its acceleration is always zero. But exception is it should move in a straight line. If it is moving in a curved path, then it is acceleration is not zero, even if the velocity is uniform. Now let us study what is non-uniform acceleration. A body is said to be in non-uniform acceleration if either magnitude or direction or both changes during the motion. If it happens, then it is said to be non-uniform acceleration. Next topic is average acceleration. What is average acceleration? It is the ratio of the total change in velocity to total time taken by the particle. So average acceleration is equal to delta v, v is velocity, change in velocity, and delta t, that is the time interval. So we can write delta v as v2 minus v1. v2 is the final velocity and v1 is the initial velocity upon delta t, the change in time interval or just time interval. So this is average acceleration. Instantaneous acceleration, AIN. What is instantaneous acceleration? It is the acceleration of a particle at particular instance of time. So it can be represented as AIN is the instantaneous acceleration. If AIN is the instantaneous acceleration, then AIN can be written as limited t delta t tends to 0 delta v by delta t, that is dv by dt. So this is instantaneous acceleration. Other way, we can define instantaneous acceleration as the first derivative of velocity. So other definition might be first derivatives of velocity is called instantaneous acceleration. So a is equal to, if a is the instantaneous acceleration here, then we can write a is equal to dv by dt, and v we can again write d r by dt. So d2 r upon dt square. This is a simple form of derivatives. So first derivative of velocity is also called instantaneous acceleration. The other definition might be second derivative of position vector is called instantaneous acceleration. So how second derivative of position vector? So this is the second derivative of position vector. R is the position vector. So second d2r upon dt square is the second derivative of position vector, and instantaneous velocity can be represented as second derivatives of position vector. Few important points let us discuss. For example, non-uniform speed is uh, if a particle having non-uniform speed, that means acceleration is non-zero. Acceleration which opposes the motion is called retardation. So to get our concept clear, let us do few numericals. So let us see our first question. First question is, The velocity of a particle is given by v is equal to 2t square minus 4t plus 3 meter per second, where t is the time in second. Find the acceleration at t is equal to 2 seconds. So we can write here, so v is equal to 2t square minus 4t plus 3. So we need to find the acceleration. So what we'll do, we'll differentiate with the time. We know if we differentiate velocity with time, then with dt, then it gives acceleration. So differentiate this equation. It is simple, d by dt, and put it here, t square 4t plus 3. And what is the answer here? Just derivative of this will be 4t, and then it is 4t, and so here one mistake is, this is minus, so it should be minus here, minus, and here also it should be minus. So we got acceleration in terms of t, but we have to find the acceleration when t is equal to 2. So acceleration when t is equal to 2, acceleration will be equal to 4 into 2, t's value is 2 minus 4, that is 8 minus 4, and answer is 4 meter per second square. This is the answer. Let us see one more example. चलिए next question देखते हैं. The velocity of the particle moving in positive direction of x-axis varies as v is equal to a under root x, where alpha is the positive constant. Let us assume that when t is equal to 0, at the time x was also 0. Find a, time dependency of velocity and acceleration, b, mean velocity of the particle for the first s-meter path. Let us see the solution. So it is given that a is equal to alpha under root x. This is alpha under root x. So if you differentiate, then we can write dx by dt is equal to, if you differentiate it, this is v. So this was v actually. So here it is given v alpha root x, and we can write v as dx by dt, and we can write same as alpha root x. Again, what we can do, we can integrate both the sides, so we can write it as, or before integration, let us simplify. Let us simplify. How? We'll put dx and root x upon root x, and what we'll put? We'll put alpha, and here dt. dt will come this side. And now we'll integrate from 0 to x, and here 0 to t. Simple integration. So this here we'll get the result as x half, this is minus half, y 1 upon root 2, so minus half plus 1, and upon minus half plus 1 is equal to, here integration Alpha is a constant, so integration of dt and limits are given, so it is alpha t. Now, so what we have done, we have written v is equal to dx by dt, and we have just solve it and just integrated it. Now, velocity we can write v is equal to dx by dt, and dx by dt we can write 2 alpha square t upon 4. So you can put it as half alpha square and t. So acceleration can be written as dv by dt, and dv by dt, what can we write? So we can integrate it here. So after integration, this is the value of v here. So if we differentiate v, this value, then what we'll get? We'll get d half alpha square t upon dt. So we are going to get alpha square upon 2, correct? Now let us see, this is the value of a and this was the value of v. So time dependency of velocity and acceleration, we got it. Now the second part, mean velocity of the particle for first estimator path. Now part B, we can write it. So time taken to cover the distance is s. So time taken to cover the distance, that is s, that is the first estimator. Huh? X is equal to alpha square t square upon 4, which implies that s is equal to alpha square t square upon 4. Then, which implies that directly we can write it as, since x is s, the distance, so we can write t. What will be the value of t? T will be equal to 4s upon alpha square, and t square is there, so it will be under root. Now we got this. Now average velocity v average will be equal to s total distance by time. So average velocity, we can write total distance upon time. So what is the total distance? Total distance is s itself, and time we have found out here, time. So under root 4s, टाइम का वैल्यू यहाँ पे बैठा देंगे, तो ये हमारा हो जाएगा, इसको सॉल्व करेंगे तो ये कितना हो जाएगा, अल्फा, ये अल्फा है, हाँ, अल्फा और रूट एस अपॉन 2, ये हो गया आपका टाइम, एवरेज वेलोसिटी, सॉरी, दिस इज एवरेज वेलोसिटी. चलिए आगे बढ़ते हैं. चलिए नेक्स्ट क्वेश्चन है, a particle is moving along a straight line OX. At time t seconds, the distance x meter of the particle from point O is given by x is equal to 10 plus 60 minus 3t square. How long would the particle travel before coming to rest? So it is a case of retardation. So this is very simple. Initial value of x, so we can write initial value of x at t is equal to 0 was how much? 10 meter. How? Just put the value of uh, t is equal to 0 in this equation. तो ये 0 हो जाएगा, ये 0 हो जाएगा, बचेगा क्या? 10 मीटर इज द इनिशियल वैल्यू ऑफ x. अब वेलोसिटी v इज इक्वल टू हम क्या लिख सकते हैं? dx बाई dt. इसको सॉल्व कीजिए. dx का वैल्यू कितना है? 10 प्लस 60 माइनस 3t स्क्वायर अपॉन dt is equal to, after differentiation we'll get 6 माइनस, इसका तो 0 होगा, 60 का 6 होगा और माइनस 6t. ठीक है, 3t स्क्वायर का 60 हो जाएगा. अब हम लिख सकते हैं when uh, when v is equal to 0. अब v का वैल्यू यहाँ पे 0 बैठा दीजिए तो 6 0 is equal to 6 minus 60. 60 उधर जाएगा तो t का वैल्यू कितना हो जाएगा? t is equal to 1 हो जाएगा, 1 सेकेंड. ठीक है, अब फाइनल वैल्यू ऑफ x निकालते हैं. फाइनल वैल्यू ऑफ x क्या हो जाएगा? फाइनल वैल्यू ऑफ x एट t इज इक्वल टू कितना? 1 सेकेंड पे. फाइनल वैल्यू ऑफ x क्या हो जाएगा? तो मान लीजिए वो x2 है, तो यहाँ पे इस इक्वेशन में आप बैठा दीजिए t का वैल्यू 1, तो हमारा हो जाएगा 10 प्लस 6 इंटू 1 माइनस 3t स्क्वायर. टी स्क्वायर तो 1 स्क्वायर. तो हमारा इक्वेशन क्या था? x का क्या था? फिर से लिख देते हैं, आपको समझने में दिक्कत नहीं होगी. ये था हमारा, तो इसमें हमने t इज इक्वल टू 1 सेकेंड बैठा दिया, तो ये आया. इसको सॉल्व कीजिए तो ये हो जाएगा कितना? 13 मीटर. तो डिस्टेंस ट्रेवल्ड कितना हो जाएगा? डिस्टेंस ट्रेवल्ड इज इक्वल टू x2 माइनस x1. ये कितना हो गया? 13 माइनस 10 दैट इज 3 मीटर. ये हो गया आपका आंसर. चलिए नेक्स्ट क्वेश्चन देखते हैं. नेक्स्ट क्वेश्चन है the acceleration of a particle moving in a straight line varies with its displacement as a is equal to 4s plus 1. Velocity of the particle is 0 at 0 displacement. Find the corresponding velocity displacement equation. अब velocity displacement equation निकालना है, तो हम स्टार्ट कहाँ से करेंगे? इस इक्वेशन से करेंगे. क्या दिया हुआ है हमें? a is equal to 2s plus 1. ठीक है, now which implies that हम a के बदले में क्या लिख सकते हैं? dv by dt लिख सकते हैं. इज इक्वल टू हम क्या लिख सकते हैं? 2s plus 1. फिर से इसको हम क्या लिख सकते हैं? dv by, हम क्या करेंगे? ds से मल्टीप्लाई कर देंगे ऊपर और नीचे, फिर dv by ds इंटू ds by dt. क्या क्या? ds से मल्टीप्लाई कर दिया, ऊपर नीचे ये कट गया जाएगा, तो हमारा कितना? dv by dt है. क्यों किया? क्योंकि हमें सॉल्व करना है इसे. तो इज इक्वल टू हम क्या लिख सकते हैं? 2s प्लस 1. फिर वापस से लिख सकते हैं ds by dt को हम क्या लिख सकते हैं? v लिख सकते हैं. तो dv by ds और यहाँ पे मल्टीप्लाई v हो गया 2s प्लस 1, ये हो गया. अब इसको हम इंटीग्रेट करेंगे 0 से v तक और और इसको थोड़ा सा और सॉल्व कर लेते हैं, वी डी वी लिख सकते हैं इसको, और इसको हम लिख सकते हैं 2s प्लस डी एस, एक क्रॉस मल्टीप्लाई किया कुछ नहीं, प्लस डी एस। तो उसी तरह यहाँ पे इसको इंटीग्रेट करेंगे, अब वी डी वी को इंटीग्रेट करेंगे 0 से v तक, लिमिट बैठाएंगे और इसको इंटीग्रेट करेंगे सेपरेटली, तो हमारा इंटीग्रेशन क्या हो जाएगा, यहाँ पे इसको इंटीग्रेट करेंगे 2s ds और प्लस ds, इसको इंटीग्रेट करेंगे, ठीक है। और लिमिट क्या बैठाएंगे यहाँ से 0 से s तक। तो इसको सॉल्व करते हैं, चलिए इसको सॉल्व करते हैं। तो ये क्या हो जाएगा, v dv का इंटीग्रेशन क्या हो जाएगा, v स्क्वायर बाई 2, और इसका लिमिट बैठा दीजिए 0 से v तक। और इसको 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 कैसे लिखेंगे, इसको लिखेंगे 2s स्क्वायर बाई 2 और 0 से s तक, और यहाँ पे इसका क्या हो जाएगा, इंटीग्रेशन ds का s हो जाएगा, और इसको लिमिट बैठा देंगे 0 से s तक। इसको फिर वापस से सॉल्व करते हैं, तो ये क्या हो जाएगा, v स्क्वायर बाई 2, और ये यहाँ पे क्या हो जाएगा, ये हो जाएगा s स्क्वायर, और यहाँ पे क्या हो जाएगा, s हो जाएगा, ठीक है। तो इसको सॉल्व वापस से सॉल्व करेंगे, तो v स्क्वायर इज इक्वल टू 2 एस स्क्वायर प्लस एस, ठीक है। तो हम इसको देयरफॉर v इज इक्वल टू क्या लिख सकते हैं, v इज इक्वल टू अंडर रूट, यहाँ पे 2, यहाँ पे क्या हो जाएगा, यहाँ पे 2 मल्टीप्लाई हो जाएगा ऐसे, हाँ। तो यहाँ पे क्या हो जाएगा, यहाँ पे s कॉमन ले सकते हैं 2s, और यहाँ पे s प्लस 1, तो v का वैल्यू ये आ गया, और ये हो गया हमारा आंसर, ठीक है। We hope that you like this tutorial. Please subscribe, like and share this video with your friends. Thank you for watching this video. Thank you very much.